Okay, so we will continue discuss the calculation of pH. So let's read the question together. For question number 1, calculate the pH when 50 ml of 1 molar ammonia react with 20 ml 0.5 molar chloric acid, and the Kb for the ammonia is 1.8 10 to the power of negative 3. So first of all, before we start calculate the pH, we need to identify the types of titration occurs. Okay, so this is the reaction between ammonia, which is a weak base, with chloric acid, which is a strong base. So firstly, we need to write an equation that represents the reaction. So the reaction is between the ammonia and chloric acid that produce ammonium chloride. Okay, so the information that we have for the ammonia, we have 50 ml 1.0 molar, and for the chloric acid we have 20 ml 0.5 molar. So as I mentioned previously, if we have the information for both reactant, we only can compare mole. So the number of mole initial for the ammonia is 0.05 mole by using MV over 1000, and for the ammonia we have 0.01 mole, and initially there is no salt produced. And the changes, because we have the number of mole for both, so the changes is 0.01 negative 0.01 mole, and also this one 0.01 mole. And for the salt produced, we gain 0.01 mole. And finally, here we have 0.04 mole, and for chloric acid 0, and this is 0.01 mole. If you look at here, the number of mole final represent ammonia, which is a weak base. If we have a weak base, we need to consider the salt produced, because it exists together, the weak base and its salt, so it is in the form of buffer solution. Okay. So now we need to identify the molarity of weak base and its salt. So the molarity is 0.04 mole over the total volume is 70. So 70 over 1000. And for this one, 0.01 mole over the total volume is 70 over 1000. Okay, so this is 0.57 molar, 571, and this is 0.142 molar. Okay, so ammonia 0.571, and for the ammonium chloride 0.142 molar. Because it exists as a buffer solution, so to calculate the pH, we need to apply the Henderson-Hasselbalch equation, which is, because it is a weak base, so POH is equal to PKB plus log the salt produced, which is ammonium chloride, and H4Cl over ammonia. Okay, so negative log 1.8 10 to the power of negative 5 plus log, so now we can insert the value 142 over 0.571. So the answer it is negative 0.604, and negative log 1.8 negative 5 is 4.74. This is the POH. The POH is 4.14. Now we want to calculate the pH. pH is 14 minus 4.14, which is 9.86. So this is the pH of the solution. So now let's look at B. Calculate the pH when 50 ml of 1 molar ammonia react with 40 ml chloric acid. So we need to write the equation for the second time. Ammonia undergoes reaction with a strong acid, which is HCl, produce NH4Cl. Okay, so mole initial that we have 50 ml, not mole initial, so this is the initial information only. Okay, 50 ml 0.5 molar, and for the chloric acid 40 ml 1.0 molar. So mole initial is 0.025 mole, and for this one 0.04 mole, and initially there is no salt produced. The changes is according to the smallest number of mole, which is 0.025 mole. And the final number of mole, this is 0, and for this one 0.015 mole, and this one 0.025 mole. Alright, so now finally we have a chloric acid, which is a strong acid. When we have a strong acid, so we don't have to consider the salt produced. So now we can straight away calculate the concentration final for acid 0.015 mole divided by the total volume, which is 90 over 1000. Okay, 0.167 molar. So this is the number of the molarity of chloric acid. And then to calculate the pH, you can write the equation. So the pH is equal to negative log H3O plus, which is negative log 0.167. So negative log answer, it is 0.78. Alright, so this is how we solve the problem that relate to the reaction between strong acid and weak base. Right, So thank you very much.